Okay. It gives me great pleasure to introduce the next two speakers. I got the pleasure of working with them on the Value Engineering Risk Management Task Force earlier this year. Two of the most organized people that I know, and they're now our new neighbors over at TLC. So today we have Zach Davis, who is the Value Engineering Risk Management Engineer, and then Peter Kennedy, who is the Program Coordinator for the VE Program Risk Management Programs. Take it away.
Thanks, Diane. So what is risk? What is value? Risk management and value engineering are fundamental components of engineering. When we design anything, we are always evaluating the value of something against the uncertainty of its performance. Intuitively, we know what makes something valuable and what makes something risky. As individuals, we practice risk management and value engineering every day. How fast can I travel on I-5 to get where I'm going on time without getting a ticket? Risk management. What's a better way to get to your destination in less time? Make your coffee at home instead of stopping by Dutch Bros for a pumpkin spice latte. Less time, less cost, less risk. That's value engineering. I'm Zach Davis, and this lovely gentleman is Peter Kennedy, and we are responsible for the project risk management, value engineering, and constructability review programs. We're here today to present to you new requirements for value engineering and project risk management. These requirements are a product of the Risk Management and Value Engineering Task Force. This task force, which included representatives from each region, kicked off in April and finished in July with recommendations to executive management for improving project delivery performance through incorporating increased use of value engineering on select STIP projects and structured risk management on all ODOT STIP projects. So we presented these task force recommendations to the highway management team, who then instructed us to go forth and conquer. As a result of that, effective on all projects kicking off after January 1st, 2020, the existing highway director for value engineering will be updated with the following new requirements. All STIP projects that exceed $25 million in total estimated project cost will be required to conduct a value engineering study. The highway directive will require the use of SAVE International Standard VE Job Plan. SAVE International is recognized as the premier organization for VE certification and promoting the practice of value engineering. The VE Highway Directive requires that VE studies be facilitated by a certified value specialist through SAVE International, and it requires the rejection of VE recommendations with a potential cost savings greater than $500,000 be approved by the region or program funding manager.
So what is VE? A value engineering study is a project analysis tool which project managers use to maximize overall value. Now, the project elements which impact value are cost, time, performance, and risk. VE studies follow a prescribed job plan to creatively find options to reduce project cost and duration, opportunities to increase performance, and strategies to effectively manage project risks. Now, the value engineering job plan systematically leads a team of independent subject matter experts through a 6-phase process that usually takes about 5 days. So how do I get a VE study on one of my projects? It's easy. Just give Zach or I a call, and we're going to make it happen for you. But the first step is to coordinate with the value engineering program, preferably before kickoff. And we're going to advise you on project scheduling and timing of the VE study, statement of work language that you should include in your A&E contracts, and a plan for coordination between the project team, the VE program, and VE facilitator. Now, as your projects begin to develop, we're going to work with you to determine the optimal timing of the VE study, as well as the primary focus of the VE study, so we can tailor it to your project's specific needs. Some examples of ways to focus a VE study include alternatives analysis, constructability analysis, strategies to manage high probability, high impact risks, and program or process improvement studies. Now, as a general rule, it's best to perform a VE study as early in the project delivery process as possible.
So in the value engineering world, we measure value using 4 key metrics. Performance. How does the product perform? This is defined through the project scope. An example of performance is if you widen a roadway, it allows for more vehicle flow, thus better performance. Time. How long until we can deliver the product to the customer? Cost. How much will the product cost to deliver to the customer? And risk. How certain are we that we can meet our performance, cost, and time objectives? All of these metrics are measurable, and we can mathematically evaluate value. Value equals performance divided by the summation of cost, time, and risk. That makes sense, right? If we can reduce cost and risk, value goes up. Inversely, if a VE alternative marginally increases project performance but greatly increases the cost and creates a new risk that adds to the risk profile of the project, then value would decrease. Nothing earth-shattering here. Well, what do we mean exactly when we say risk? Risk represents uncertainty. PMI defines risk as an uncertain event that, if it occurs, has a positive or negative effect on one or more project outcomes. Now, we can all agree we do not work in an environment of absolute certainty. Far from it. The intent of managing risk is to identify threats and the opportunities of the project and to minimize the threats, maximize the opportunities, and shift the odds in favor of project success. Because of this, with the full support of our highway management team, the risk program has created a highway directive with the vision of capturing the benefits of risk management and reducing the amount of liability you are exposed to in delivering projects. The Project Risk Management Program has been established to support ODOT's commitment to continuous improvement in delivering our projects and programs on time, within budget, while maximizing overall value. Effective on all projects kicking off after January 1st, 2020, a new highway director for risk management will be released with the following requirements. All STIP projects will be required to have documented risk management in the form of a project risk management plan. All STIP projects will be required to update their project risk management plan at each identified project delivery phase gates. All STIP projects that exceed $25 million in total estimated cost will be required to conduct a cost risk assessment, which produces risk-based cost and schedule estimates for the project. And the highway director requires that TPMs and RECPs be the default risk manager during design. During construction, the project risk management duties shift to the RE. To assist regions in documenting risks, the risk management program has developed a project risk management job plan.
So we researched and performed best practice studies on ways that leading DOTs manage and document project risks. We then took, or perhaps even stole, the best practices and customized a job plan and companion tool to best suit ODOT's needs. When developing this job plan and risk analysis tool, we had 2 guiding principles to follow. It needs to be intuitive and it needs to be effective. Now, this is a quick overview of the job plan. We always begin by determining your project's risk tolerance. We move into identifying your risks, analyzing those risks, and developing a risk response strategies. And of course, we need to act on those. And then we're also documenting all along throughout the process. It's never too early to perform a risk assessment on your project. Now, in the future, the scoping team will provide the project team with a risk register with scoping assumptions as a launch point. Now, this is a blank example of the project risk management tool. The tool was designed to efficiently guide a project team to efficiently go through and document the findings along the way. So let's look at the tool from left to right. Now, in the risk identification section, you identify your risks as a threat or an opportunity, you title it, and provide a detailed description. Now, moving to the center, in the assessment section, you analyze the risk by assigning values of 1 to 10 for probability of occurrence and cost and schedule impacts. In the risk response plan section, you determine the risk response strategy and action and assign a risk owner. And on the far right, in the risk monitoring and control section, we document the outcomes. Now, this process is then repeated at each phase gate. Now, this tool has got the capacity for 30 total risks. Now, if your project has more than that, contact us and we're going to create a specific version for your needs.
Prior to identifying the project's individual risks, you must first identify the project's individual risk tolerance. For example, a project like Rose Quarter at about $500 million will have far more tolerance for a $500,000 risk than, say, a $4 million preservation project. To do that, you ask the project team the following two questions. At what cost impact due to a risk event should the project team devote significant resources to prevent the risk event from happening? For example, if your project has a $250,000 risk event, should your team spend a significant amount of time and money preventing it from happening? Time and resources are precious, right? So we want to allocate them appropriately. If you had a $2 million project and it had that $250,000 risk event, then yeah, you probably would. But a $25 million project, maybe not. However, it depends on what the other identified risks on the project are. What we're asking with this question is, when does the risk really matter? Why do we ask this question? Two reasons. One is to not waste time discussing insignificant risk. Let's say your project has a risk of unsuitable subgrade. Well, if the maximum cost impact of that risk is $50,000 and your risk tolerance, as identified by the project team, is $500,000, document that risk and move on. Don't spend a significant amount of time analyzing it. The second reason is to provide us for a basis of rating. More on that in a moment. The second question is, at what duration of schedule delay due to a risk event should the project team devote significant resources to respond to prevent that risk event from happening? The principle is the same. If a risk event can delay your project by 8 months, you're probably always going to want to avoid that. But a 3-week risk, likely you can live with that. However, if your project has an aggressive timeline, then maybe not. The point is that risk tolerance is project specific. These questions should be asked and answered with the project team in a workshop setting so the project team can agree on what the project's appetite for risk is. Don't spend any more than 10 minutes on this process. If the project team can't agree, you, the risk manager, needs to set the values and move on. From the results of risk tolerance calibration, the project risk sensitivity table is automatically generated. This table is referenced by the tool during risk rating. The purpose of risk rating is to give the team guidance on which risks are of the highest priority. The project team's risk sensitivity may change during risk analysis. If so, return to the risk tolerance calibration and adjust the values. The project risk sensitivity table will automatically update, as will the values in every phase gate risk register. Therefore, the risk tolerance section should only be modified during the initial analysis.
So the next step in the process is to identify your risks. Risk identification is ongoing throughout the project development. As projects evolve, the risk profile changes as project understanding grows. Previously identified risks may change and new risks may emerge. Now here's a recent example of a risk identified on an actual project. Now as you can see, this risk was identified by the project team on June 14th as an active threat. This risk is categorized as a utility risk, and the project team provided a detailed description. So a few tips for risk identification. You want to focus on identifying large and significant risks that affect project objectives. You want to carefully document and describe your risks, and be mindful of possible biases during the risk identification process.
Now that the risks have been identified, it is time to analyze them. For the Project Risk Management Plan tool, we will rate the likelihood of a risk occurring and the cost and schedule impact on a scale of 1 to 10, using the risk sensitivity table as our framework. The intent is to determine the magnitude of the threat or the opportunity. The tool will automatically populate the heat map red or green depending on if the risk was identified as a threat or an opportunity. The Project Risk Management Plan tool provides what is known as a qualitative analysis. The project team rates the probability that the risk will occur, and if the risk occurs, rates the cost and schedule impact on a scale of 1 to 10 to categorize the risk as negligible, low, moderate, high, or extremely high. The values in the risk sensitivity table are tied to these categories and are used to hone in on the cost and schedule impact rating of the risks. Don't allow the project team to get bogged down in a debate on rating risks. If one project team member says the risk is high and another says it's very high, the risk manager just needs to make a decision and move on. If one project team member says a risk is very low and another project team member is adamant that it's very high, call it a moderate and move on. We want to be reasonably accurate, but not unproductive, especially when it comes to risks that may fall below a rating of low in cost and schedule impact. For projects that have high impact risks, we have an advanced risk assessment process that goes beyond the qualitative risk assessment and that it actually quantifies risk and schedule impact through engineering judgment. An example of that would be if this risk triggers, it will delay our project 8 to 10 months and cost $1 to $1.5 million. That's what we mean when we say quantify the risk. This process is called a cost risk assessment. A cost risk assessment typically includes a 2-day workshop with the project team. The length of the workshop depends on the project and risk size. For example, Rose Quarter has multiple 5-day risk workshops. In this workshop, risks are identified and quantified by the project team members in terms of how likely is it that the risk will be triggered, what is the cost impact range of that risk, and what is the schedule impact range of that risk. Does that sound familiar to the Project Risk Management Plan tool? It is. The Project Risk Management Plan tool is very close to quantified risk analysis, but it's not quite there because it's confined by the project risk sensitivity table. However, the vision is that on select projects, we can easily scale up from the Project Risk Management Plan tool to a cost risk assessment. Oh. Yeah. No, I'm good. Why? Because cost risk assessments produce risk-based cost estimates and schedules. They produce forecasts of probable outcomes, and they replace the standard practice of applying contingency with a strategic risk reserve. What is risk-based cost estimating, you ask with great enthusiasm? During the cost risk assessment workshop, when the probability, cost, and schedule of a risk is quantified, an expected value for that risk is calculated. This is done for each identified risk. Then risk modelers like Peter Kennedy use a statistical analysis technique called a Monte Carlo simulation to produce a probability distribution of estimated total project cost with an associated confidence level. What a Monte Carlo simulation does is simulate the project 10,000 times with random risk events triggering. When the risk event is triggered, its expected value for cost and time is added to the total base cost estimate and schedule for the project. Now, this is an example of a probability distribution from a Monte Carlo simulation of a small project. What we can ascertain from this distribution is that we are 80% confident that this project will be delivered for $3.69 million or less, based on the project's risks. This method is more accurate and realistic than simply applying a design contingency, which is nothing more than an arbitrary percentage applied to the total base cost estimate of the project. We can give you cost with confidence and a report that documents why the project was anticipated to cost a certain amount. Now, don't worry about performing this process. Peter and I will do that for you. All you have to do is call Peter or me and say, I want a cost risk assessment, and we will make it happen.
So it's not enough to just identify risks. We need a plan for how to respond to them. Now, using the rating from analysis, we can prioritize risk based on the risk score. Once prioritized, we can then determine what strategy and level of investment is best for response. Now, there are several basic risk response strategies. Now, for threats, we mitigate, avoid, transfer, and accept. And for opportunities, we enhance, exploit, share, and accept. Now, the most common risk responses are to mitigate threats and enhance opportunities. Now, it's important to have a detailed description of the risk response strategy and assign a risk owner who will then be responsible for taking that action necessary. Now, project risk managers and those assigned to a particular risk must take action to respond to the identified risks. Focusing on risks of the most significance will shift the odds in favor of project success.
We must take action. Sometimes it can get muddy or be a burden to carry, but the sooner project risks are resolved, the better the decision making and the higher the probability of a successful project. That's my boy, and we love doing Spartan races, which coincidentally are very similar to delivering projects, and that they're very challenging obstacle course races. Now that we have taken action to respond to the risk, we must monitor and control it. What actually happened? Did we mitigate the risk? Did the risk change? Did we meddle? In this section, we monitor identified risks and the planned risk response strategies for their effectiveness. Activities involved in risk monitoring include evaluating effectiveness of actions taken, identifying the status of actions to be taken, tracking risk response, and communicating risk management status and risk response follow through to the area manager and project sponsors as appropriate.
So at each subsequent phase gate, we're going to repeat the process. Now, as mentioned earlier, all ODOT STIP projects will be required to update the risk management plan at the completion of each phase gate. Now, this process includes versioning of the risk management plan for project documentation, reevaluating each risk status, re-rating the risks to track the reduction or gain in risk score, and updating the risk monitoring and control section with a narrative describing risk response actions taken, which might actually include risk retirement. Now, the risk management plan should be generated during initiation at or around kickoff and updated at the region phase gate, DAP, preliminary, advanced, and PS&E. Now, during the construction transition phase of the project, a construction handoff meeting shall be held specifically for the risk management plan. This includes, at a minimum, review of the risk management plan, specifically highlighting high severity risks, review of the risks that have been accepted as a response strategy, identifying, analyzing, and developing any new risks that have arisen since the PS&E phase, and finally, documenting that the handoff meeting actually occurred. Now, Zach is going to now take us on a brief tour of the tools that are available for you to manage your risk profiles on your projects.
Thanks, Peter. During the last scoping cycle, this tool was developed by others, not myself, to assist in assigning contingency to a project based on the risk potential due to the project's scope. So I'm just going to dive right into going through it because it's pretty simple. Okay. Good. Okay, so there's actually an extensive instructions tab on this, so I'm just going to give kind of a high-level overview of it. So for an example, what we're going to use today is nothing from Halloween City. It's just a rural multi-span bridge, pretty boring. So how you use this is you go through these different categories. So they've got complexity, right-of-way, environmental factors, estimating confidence, scope creep, and change. And you look at the elements in the project scope, and based off of those elements, you assign basically a risk factor to each individual category. So green here is tied to 1, yellow here is tied to 2, 3, orange, and 4, red. So if we have a rural multi-span bridge, for this one, if you're looking at complexity, it's obviously more than a 1R pave, more than a 3R preservation. It's a multi-span bridge, so you would just input a 4 here for a complex bridge structure. And of course, you'd be documenting your rationale for that here in the comments section. Then you move down to right-of-way. This is a fake project I made up, basically, so I'm gonna say it actually does have some right-of-way acquisition, rural right-of-way, 3 for orange. Environmental factors, well, it's a multi-span bridge, probably looking at a couple of years or a couple different in-water work seasons, so it's absolutely more than these first 2 categories. Minimal in-water work, I'm gonna say extensive in-water work, so you would just apply 4 here, because again, it's in the red category. And then estimating confidence. So for this fake project, we'll assume that I put together the cost estimate using the skills I learned as a contractor bidding and building ODOT projects. So I'm pretty confident in a detailed scope and estimate. So I'm gonna go with a 1 on this one. And then for scope creep and change, again, this is more in a rural pave only. Clear problem statement's probably about right. 80 ramps present, not likely, and it's not an urban project, so you'd assign a 2 here for that. So the way that this tool works is as you're inputting these factors based off of the project's scope, this calculation is going on in the background and it spits out a risk factor for you. And what that risk factor does is it drives your contingency. So for this specific project, my risk factor is 1.4, so that replaces contingency. Essentially, that's equivalent to a 40% contingency. If you have projects that have a lot of risk potential, again, based off of the scope, you could have as high as a 50% contingency, or if you have a pretty clean, straightforward project, like just an inlay project or something like that, you could go all the way down to a 20% contingency. So that's as far as I'm going to cover that tool. But before I move on, I wanted to point out that this tool, it's limited in that it does not have the capability to identify individual project risks. However, it's a better method than applying an arbitrary contingency percentage. And within the next year, the risk program is going to work with this tool and the project risk management plan tool on integrating the two together. You're going to see the project risk management plan tool in just a moment. And so the scoping team can have a tool that they can identify risks with and use those identified risks to inform the risk factor for the project. So let's move over to the project risk management plan tool. If I can do this right. Cool. All right. So this is the project risk management plan tool. Throughout the presentation, you've seen a bunch of different little screenshots. So hopefully with this, it'll tie everything together for you. So the way that this is intended to work is you start in the base tab with key project information. This is the only place you have to put this. I know you have to do this a lot and it's redundant, so we only put it in here once. So the project name, obviously here, key number, risk manager, area manager, and then total estimated project costs. And when we say that, we mean everything it takes to deliver it, right away, utilities, PE, CE, construction. And then total project duration, the entire project duration from design to third note. We're trying to gauge the project size. And that's going to inform our risk tolerance a little bit. So if you had, let's say, a $60 million project here, you can use that as kind of guidance to set your risk tolerance calibration. Now, for the examples I have in this risk register, I'm actually going to use ODOT agency risk. I didn't want to use a specific project, and that'll make more sense in a moment. But my risk, as a result of that, my risk tolerance calibration values are huge. So I'm kind of saying, we're not doing anything until we hit $20 million. That's not going to be true for a project. You're going to be, unless you have a huge project. As you go through this document, there are these text boxes that provide guidance, at least they're intended to. And there's also these red flags, which are comments, which you can just hover over and it will tell you maybe a little bit of guidance here. This one happens to tell you that the default value, when you download this file from the internet, is going to have $500K in there for cost impact and 6 months for schedule impact. And you're welcome to use those for your risk rating purposes or adjust the tolerance to your project specific. As I mentioned earlier, these values automatically feed into the project risk sensitivity table. They are essentially your midline values, your moderate values. So if you can recall, I had 2 years of schedule impact, 20 million at cost impact. 2 years is my 5, 20 million is my 5. So from 5 to 1, you go from a moderate to low or negligible in severity. And from 5 to 10, you go extremely high. So once you perform your risk tolerance calibration and take a look at the project risk sensitivity table, you're ready to just jump right into a risk assessment. Before I do that, I wanted to show you a few other tabs. In addition to these text boxes and the comments, there is a guidance tab. And this is intended to answer any question you might have. It goes into purpose, objectives, why are we doing this, why do we want to do it, scope and context, guiding principles, roles, responsibilities, all that good stuff. You can look at that to answer your risk assessment questions, or you can just call me, whatever works for you. So there's also a sortable report here. The way that the project risk management plan is set up, this is the project risk management plan. I need to scale it a little. You can't sort this because there's just too much going on. So there's a sortable report here that's linked to the most recent risk assessment data you put in here. That way you can sort your risks by what's listed here, whether it be the score, what your priority was, what your strategy is, who the risk owner is. And then there's also a glossary tab. So this glossary tab, for now, only includes risk response strategies. We're actually a part of international community international community for risk management, and we're working on a glossary for risk management terms. So in order to avoid confusion, I've only basically put the bare minimum in here, and then we're going to update this at a later date. And this process is, or this tool is not necessarily in the preliminary stages of development, but it's absolutely still in development. So as you guys go through and you're using this, or when I come out and we go through a qualitative risk assessment, please provide feedback and we will incorporate that as we go along, because this is still in development, although it's ready to be used now. So this is the Project Risk Management Plan tool. So for these other tabs here, each one of these tabs is your phase gate specific Project Risk Management Plan, and they're all linked. So whatever data you put in here will automatically feed into tab 3, which goes into tab 4 and 5. And the reason for that is that we want to version this document as we move through the project development process. I want to put a button in here to where when you finished with the initiation project risk management plan, you hit, I don't know, done or lock or something, and it just locks it, leave it alone. Because we want to be able to version this and track the risk development with project development. Okay, so let's just look at some of these risks here. So I've got 3 risks listed, and again, these are agency risks. And there are far more than 3, but for the purposes of today, I just have the 2 that I'm heavily involved with, 1 that I'm slightly involved with. So the first risk here was identified before I was even hired by someone in the statewide project delivery branch. And it's an opportunity, and the risk title is Formal Project Risk Management on STIP Projects. The detailed description is TPMs and RECPs, although they wouldn't have been called that at that time, should be able to increase control of project scope, schedule, and budget through the use of proactively documenting and managing inherent project risks. Also, when this risk was initially identified, I doubt that they would have had a probability of occurrence this high. The reason why it's this high is because, well, preferably, you all find the benefit in using this process. If that doesn't work, there's actually a highway directive that requires it, and it's also going to be a DAP deliverable. So if you don't have a complete project risk management plan at DAP, they're going to kick it back. We don't want to do that, but we'll see what happens. And the cost and schedule impact would probably also not have been rated this high. So you see here this number here, I've rated this as greater than $40 million in savings. Now again, we're looking at agency level risks. And when I was looking at this is my personal assessment. Since this is an agency level, there's many projects in it, I confined it to a STIP cycle. So think of all of the projects in a STIP cycle and applying this process to it for cost, impact, and schedule delay. WSDOT, who's about 20 years ahead of us in risk management development, they tracked the performance of their risk management program by looking at projects that had formal project risk management and ones that did not. And they found a significant decrease in things like change orders that resulted in substantial cost savings and schedule savings. So that's the justification for this impact rating here. So this risk is identified, it's been assessed, and in the workshop process, usually the way we like to do it is you identify the risk, then you assess the risk, then you stop, and you move down to the next risk. Identify the risk, assess the risk, and you do that for all the identified risks. Then you go up and you take a look at your risk score for each risk, and you can use that to determine what your priorities should be. And from there, you do your risk response plan because you'll have an idea of how you're going to allocate your resources. Okay, so the next risk, risk 2, is, again, it was identified before I was even hired into this position. It's an opportunity. It's value engineering on projects that are less than the FHWA thresholds. So for those of you who don't know, FHWA requires value engineering on all projects that exceed $50 million. So this is specific to projects less than that. And the description of this risk is the increased use of value engineering may result in projects that can be constructed faster, cost less, perform better with less negative risk events. Pretty high probability of occurrence. Again, when whoever identified this initially may have not thought it would have been that high, but since we've gone through and went through the task force and everything like that, we have requirements in place now that kind of push that up, which is a good example of why you want to perform risk management early, because the probability of occurrence has changed since we've gone through the task force, at least I would assume. Then the cost and schedule impact rating, and again, when you're going through a risk assessment, you're probably not going into this much detail, but you also you will need engineering judgment to inform what your potential cost and schedule impacts will be. The cost and schedule impact for VE is easy in that it's a direct output of a VE study. So we recently had a value engineering study that resulted in an $8 million savings to the project, and it saves 6 months in construction schedule. So it's pretty easy to imagine that you can get up to 40 million in 4 years. And in fact, we actually ran an analysis on the last STIP cycle, and had we done value engineering on projects that were 25 million or more, we would have expected to see a savings of $75 million. Anyway, the third risk is inaccurate project cost estimates. It's a threat, and this inaccurate project cost estimates is referring to any of them. So scoping to PS&E. The description is inaccurate cost estimates may result in misinformed decision making. A lot of our decisions that we make are cost-based, right? So if we don't have the right information, how can we make the right decision? Inefficient program and project management, delays to the project completion, and the associated economic impact of delayed infrastructure maintenance and modernization. Anyway, a lot of stuff in there. Based off of STIP amendments and things like that we've seen, we think, or again, this is my rating, we think this is happening at about 50% of the time. And it appears, in my opinion, it's extremely costly and causes a lot of issues on the schedule side of things. But again, this is my rating here. So, okay, so once you go through and identify the risks and you rate them, then you drop back and you do your risk response strategies. So these two opportunities, risk management and value engineering, are what we call golden opportunities. And the strategy for these is to exploit them. So do everything in our power to make them happen. The risk response strategy for all three of these risks by the statewide project delivery branch was, part of that was actually to hold a task force. So we had the VE and risk management task force, there was the cost estimating task force, and there will be a scoping task force. So again, anyway. So the risk response plan, we go through, we're exploiting it through the task force efforts and other things of that nature, and then we go and we monitor and control it. So part of this presentation today is actually part of our risk response plan. Our task force is complete, tools are in development and developed, we can use these now, and we're presenting these tools in this process at the Project Delivery Boot Camp. So that about does it for what I was going to show you on the project risk management plan. So let me switch back over here. Oh, it looks like I closed the PowerPoint. Sorry about that. Oh, I got you. Okay, thank you. Okay, now, through the development of a project, you're always handling risk. This is not something that's new to the agency. Risk management is something that you and your project teams are already doing. What we're asking with this process is that you document the risks and discuss them as a design team. The project risk management plan tool, highway directives, an example risk list, some templates, and all of that the resources that we are developing will all be available on a project risk management, value engineering, and constructability review external website that will be available soon. We're working on it now. We'll let you know when it's up, and in the meantime, contact us directly for any of these resources. If you want a VE study or a cost risk assessment on your project, again, all you need to do is call us and we'll make it happen. If you would like a qualitative risk assessment on your project, which goes through the project risk management tool, which again will be a requirement, again, just give us a call. Or after this, if you want to talk more, we can set something up. Our risk management training strategy is to conduct live qualitative risk assessments on projects that are going on right now. So we are happy to travel to any corner of the state and get you on your feet for formal risk management for your project. Consider us a resource. We're here to support you in overcoming the challenge of delivering your project ahead of schedule and under budget. So thank you for your time. Any questions?
Just more of a comment. I was on the VE study with Zach and Peter for the Aurora Donald. I went in fairly skeptical of the amount of money that they said per dollar they could save. But going through the process, and the project lead was quite reluctant at the beginning of it. But I believe it came out for every dollar that was spent, I think it was like around about $110 savings, something like that. So for every dollar they spent, they saved 110. Using the risk tool, it was very quick. It was easy to use. It looks a little complicated in the beginning, but they're worth every bit of it. So embrace them, and you'll be pleased with the results.
Thank you for that.
Thanks.
There's one point I wanted to make is I understand that this tool probably looks pretty complicated, but once you go through it, it's actually very simple. We've done a few of these risk assessment workshops. We did one recently up in Portland, and once the risks started flowing, it just became like a really productive workshop, and everybody involved seemed to be very pleased with the end product, which is a full risk register, which is a plan that you can take forward and move on.
Hasti.
Besides the dollar amount on the project, what other type of projects would be a good candidate to utilize this?
For a risk assessment or a VE study?
For more risk assessments,
Okay.
the cost or qualitative.
Projects that tend to make good candidates are ones that have a lot going on, right? So like urban projects that are constrained, you've got a lot of different right-of-way issues, utility issues, things like that nature make good candidates for demonstrating the process.
One of the things that I noticed is missing from the tool is when your triggers are determined. So is there a specific reason why you didn't list when your triggers are going to hit for each one of those threats or opportunities?
So we wanted to start as basic as possible and then build up from there. So that's one of the reasons why we kind of just went bare bones, because we don't want to roll out something that's overly complex that people may have a difficult time using. Because we want, again, as Peter mentioned, it to be intuitive and effective. And then from there, we will build our competency as an agency in risk management.
Part of our strategy is going to be going out to the regions and doing pilot studies. And during those pilot studies, we're going to be gathering that exact feedback, and we're going to be creating new versions and improving over time. That's been our strategy so far. And I'd also like to add that the requirements that we were talking about are going to be in the form of two highway directives that all of you are going to have an opportunity to comment on. And so if you don't have them already, Diane's going to be forwarding those to all of you, and they're open for comment and review right now, so we can still tailor these programs to your needs. But those directives were the direct result of the task force that we alluded to before, which was represented by all of you and folks in the regions as well. So please do take a look at those, and that is your opportunity to help shape these programs.
One of them.
Zach, if every project is required to have the risk management plan, is the typical project going to have the project team complete this and then submit it? Or is every project also required to have a risk management interaction specific team meeting for this?
So the idea is that this process would slip into like a typical comments review meeting where you're discussing risks anyway, right? So the idea is that you would, your initial risk analysis tends to take a little bit of time, but as you go through the project, you may identify one additional risk, two additional risks, but you're mainly monitoring and controlling, okay, what did we do? What happened? Did the risk change somehow? Did the probability of occurrence go down because of our risk response strategies? And the idea is that this process would slip in with something like a comments review meeting. Does that make sense?
Other questions?
So I appreciate your presentation. There's a couple of things. One is reliability. So how many inputs are required for each and every risk assessment to get to a point where you actually have a plan and mitigations? That's one point in terms of numbers of times that we have to do this for each and every project.
Mm-hmm.
And the other part of it is, in this case, we're looking at known unknowns, correct? So we're not looking at exogenous impacts to projects, correct?
Yes. So, like known or unknown unknowns are things we don't know, right? They're the things that we just don't know. With this, we're looking at our known and known unknowns, meaning that we know it's a risk, but what is it? And I'm trying to explain it a little better here. Okay, so a known unknown in that it's your risk, and it's a risk because it is uncertain. We don't know what's going to happen. So that's the point of this, is to look at those uncertainties of the project and focus on the uncertainties of the project that really matter, that can really either derail us or get us ahead, with it being a threat or an opportunity. That's the idea in this process, is to manage those. Which again, we're currently doing, but this is an opportunity for us to perhaps do it a little better with this communication tool, which is effectively what this is. It's more of a communication tool, because again, handling risks is what we do when we're project managing. This is just asking that we write these things down and we talk about them as a design team, and we track them throughout the project development process.
Any other questions for Zach or Peter? Okay.
So Zach, Peter, thank you very much. Really appreciate the presentation.